Yeah, we were on a stage where we were trying to analyze the mode. So we have equated the first derivative 0 and our x is a 1. Now before substituting, of course, for us to test whether this x value is going to give us maximum value of f of x, then we must have the second derivative. So our second derivative of x is negative 6 over 8. But then, before putting in this x value in the second derivative, you first ask yourself, is the second derivative which I want to test to check whether it is the mode, does it follow in the range of the values of x in which the PDF is defined? So my x value after equating the first derivative to 0 was a 1. I'll come here and check. My PDF was defined from 0 up to a 4, and 1 is definitely between 0 and 4, which means that 1 can be the what? The mode, because it is in the range of the values of x in which the PDF is defined. So having gotten the second derivative in this step, because I want to check whether this one can give the maximum value of that, I now get the value of x and substitute it in the second derivative. And if the result is a negative, then our x value is given the maximum value of f of x, and therefore it is the what? The mode. So when x is 1, my f double prime of 1 is going to become negative 6 over 80, and because we do not have x this side, it's a constant function, so whatever x value that you put in, this one does not change, and therefore f double prime of 1 is a negative 6 over 80. So since f double prime of 1 is less than the 0, in brackets it is a negative, it implies that the mode is equal to a 1, because it is a 1 which is satisfying the condition that the second derivative must indeed be less than the 0, because it is already a negative. So that is all about our first example, but we are supposed to do 2 examples in the nonlinear ones. Now, in the second example, this is our second example, and this is how it is defined. So in our second example, they are saying that a random, in example 2, a continuous random variable x has a PDF small f of x given by, so our small f of x is a kx squared into 3 minus x. This is when x lies between 0 and 3, and it is 0 elsewhere, where our k is a constant. And required from us is really find number 1 the value of k, and after finding k, we shall definitely find the mode. So that is our question, and we want us to get the mode, that simple nonlinear PDF. So we are still following the same steps only that this time we are going to have the two values of x, where one can be the mod and the other cannot be the mod, because when you substitute them in the second derivative, one gives a value greater than 0 and the other gives a value which is less than a 0. So in the solution, we said that whenever you want to get the value of k in first state, the property of the PDF that you are using, and because we are dealing with the PDF of a continuous random variable, so when you integrate from negative infinity to positive infinity, and we are integrating the PDF with respect to x, the answer should be a 1. So our PDF is known. It is f of x is equal to kx squared into 3 minus x. This is when x runs from 0 to 3 and it is 0 otherwise, or 0 elsewhere. So we go to this, where there is negative infinity, we are going to put a 0. Where there is positive infinity, we are putting a 3. So we shall have the integral from 0 to 3 of where there is f of x, we are going to put this of kx squared into 3 minus x dx. The answer should be a 1. So we shall pull out a k. So when we integrate from 0 to 3, and we are integrating x squared into 3 minus x dx, the answer should be a 1. So the class will check and see whether k is a 4 over 27. So part B wants the mod. Now for us to get the mod, we shall firstly define our PDF, because it is a simple one. So my PDF f of x, it has only one interval, that is why we are referring to it as being simple. It was a kx squared, but now k is known, so it is a 4 over 27 x squared into 3 minus x, and this is when x lies between 0 and 3. So that is our initial step. The second step, because we want the mod, is to differentiate that function and equate the first derivative to a 0. So this is our original PDF. Our f of x, we can simplify it further so that we can remain with only a constant out and then differentiate easily. So our f of x is now 4 over 27 into 3x squared minus x cubed. That is when this x enters. So the first derivative of x, which we denote as f prime, our f prime of x will now be a 4 over 27 into, what do we get when we differentiate 3x squared? This one drops and reduce the power by 1. So you have 6x. What do we get when we differentiate this? We are going to have a 3 but x squared, and that will be our first derivative of the original function f of x. Now, at the maximum value of f of x, our f prime of x must be a 0, implying that our 4 over 27 into 6x minus 3x squared will be a 0. So when you multiply both by 27 and you divide by 4, you will realize that 6x minus 3x squared is a 0. This is a quadratic which we are going to solve by factorization. So what is common here and there is x. X is common. What is common still here and there, because this is divisible by 3, even if it is common. So we shall remain with a 2 minus a 3, not minus a 3, minus x is equal to a 0. After pulling out 3x, it's a 6x divided by 3x, you get this 2. After pulling out 3x, you say 3x squared, 3x squared divided by 3x, you realize that the answer is anti-x, then you say that it will reduce to that one. So from the 0 principle, if you are multiplying two numbers and they are being equal to 0, either the first one will be a 0 or the second one will be a 0. So either 3x is equal to 0 and our x is a 0, or 2 minus x is equal to 0 and our x is a 2. So one of these two x values is going to be our mode. It will either be x is equal to 0 or x is equal to, they are all candidates of being probable values that can be the mode. Now we are heading for the testing of whether this is the mode or this one is the mode. But before we go ahead and test, we first ask ourselves, is 0 in the range given? So x is equal to 0. Our range is stretching from the 0 up to a 3, and 0 is definitely part of the values. Even when this was strictly less, we will still say that 0 is part of them because these are continuous random variables. The other value is a 2. And also a 2 lies between 0 and 3. So because all those two values are within the range of the values of x in which the PDF is defined, so they are all probable candidates of the mode. You can conclude that the mode is this or the mode is that. But before concluding, we must always first test them in the second derivative. So we are going to have our f of x is known. We are now testing for the mode. But how are we testing? We want to have f of x. Our f of x is a 4 over 27 into 3x squared minus x cubed. The first derivative of that function is the 4 over 27 into 6x minus 3x squared. Now the second derivative, which we are supposed to use to test. If you want this, differentiate this. If you want f double prime, differentiate f prime. So we shall have a 4 over 27 into 6. When you differentiate 6x, you get 6. When you differentiate negative 3x squared, you get negative. These 2 drops, and it is 3 times 2, which is a 6, then x. So that is our second derivative of x. Now we are going to pick each x value at a time, and you put it in the second derivative. Checking x is equal to 0. So when x is 0, our f double prime of 0 is going to be 4 over 27 into 6 minus 6 times 0. You have to show substitution. So my f double prime of 0 is going to be 24 over 27. Then I will ask myself, is 24 over 27 my f double prime of 0 is 24 over 27. So I will ask myself, Is 24 over 27 less than 0? If yes, then this is the mode. If no, it is not the what? The mode. So since this value here is greater than 0, since f double prime of 0 is greater than 0, then x is equal to 0 is not the mode. Then we check for the second one. So we are checking